Hello, we are from Group 14 TA 2021. Would like to present our implementation research about embedding from language model representation based bidirectional low short-term memory and conditional random field model for Indonesian name entity recognition. The first one you have to do is load data or import library. The implementation is done by loading the data first. To load data, import data is carried out, which can be used to meet the needs of library that can manage the data. The type of library used at the load data implementation stage can be seen at the first line. For data analysis, we need Pandas, NumPy, CSV, NLTK, and TensorFlow. And for data visualization, we need Matplotlib and Seaborn. Next, the dataset is previously stored in the Google Drive. Storage a dataset on Google Drive is useful so that the data does not need to be entered repeatedly every time when we call our data. The previous dataset only consisted of 2 columns. Therefore, the dataset needed to be converted into 3 columns. Previously, the dataset needed to be parsed or converting the data into a form that can be read in the program using list. Determiner T used as a separator with the types. And then, after the dataset has been successfully converted into the data frame from using Pandas library, it will get the following head display. There are 3 columns, namely token, entitas bernama, and kalimat. And for the last 5 data display, token, entitas, and kalimat, namely 3 columns with the tail function. Dataset info serves the information about the dataset, namely column token, entitas bernama, and kalimat, and we can see that memory usage 30.5. The second, we have to do exploring or visualization data or analysis data. Since the dataset is annotated with text name entities, we will build a simple class to combine words into sentences. This will help us better understand the dataset or data visualization. Next, the implementation is carried out to see that the sentence and its entities as whole. This is done by function getterSentences. To see the longest sentence, we can use a max function, namely 120. To show the longest sentence, we can use print function. The result will be like this. To see the shorter sentence, we can use min function. And after that, we can use print function to display the shortest sentences. Namely, there are 8. To show the sentence, we can see here by using print method or function. Next, we can count the calculation of the name entities, and then calculation of the sentence, unique word, and name entity. The result obtained that there are 44,423 the number of the sentence, and then 94,579 the number of the unique word, there are 4 named entities, namely O, place, organization, and person. And then next we can see the word take as a place. We can see by head function we can see that there are the first 5 of the token that take by a place. And then to see the slicing of the data set, for example, we can use ilog to see the order of 520,085. So it will be displayed like this. And for word that take by a person, it will show the result like this: Sadat, Anwar, Sadat, Hafiz, and Asad. This token is taken by a person. And then to see the word that token that labeled by the organization, there are 4 because we make the head function, namely Universitas Indonesia Independen, Universitas Gajah. And word that take by O or other is ia menjabat sebagai presiden ketiga. The next, the calculation of the entities in the dataset is performed by the function count. The dataset will be sorted by the name entities. In the dataset, a name entity was calculated for each token or word. From the calculation, the following result will obtain. To see the distribution across the entities, we can use the type layout. And then the function is used in the pilot module of the matplotlib library to automatically adjust the subplot parameter to provide the specific padding so that the subplot match in the drawing area in this function. And then to see the word distribution of name entity except O entity, it's necessary to set the class figure, then use this as the default value and set the image size before plot. From the 2 image, this one and this one, we can take the conclusion that the number of token label O is greater than the other entity. Okay, my friend will continue our presentation.
This one to display the first 20 tokens that have appeared the most. And this code is used to see the URL that appears in a data set such as HTTP or www URL. Next, to calculate the number of punctuation like point, commas, slash, apostrophe, and dash. After that, we have two text pre-processing. The first one is to expand construction. We have to fix the writing format on the token column because the structure of the dataset is not clear, so we need to make the change by placing punctuation marks so that every token followed by a period will be add a space after that. This one. After that, we create a construction dictionary which will be used to compare tokens in dataset and replace them with new words. This is the construction this we use, and this is what the construction dictionary we have to change. This is data set before we expand. We can see that Dr. Andus is the RS will change Dr. Andus. The second one, we have to case folding. This is to lowering the text in our dataset. The third one is we have to bio-annotating. It can see that the token without label O will tag with B tag, and after that, after B tag, we have to tagging it with E plus tag. As we can see, the first one is Padang is tagged with B place, and after B place, we have to token it with E place. After we have bio annotation, we have to change entitas bernama and replace it with bio annotation. Here are the new column for our dataset. Finally, the number of available entity tags in our dataset is B organization, B person, B place, B I organization, I person, I place, and O for other.
So we have already our pre-processed dataset, and same like our dataset before. In this our pre-processed dataset, we have to get the sentence, and to get the sentence, we use class get sentence. Class is a template for object, so this is our class get sentence, and this is our to get an object. When we define a method for a class, we are required to set self data as the first parameter, and after that we use lambda function because lambda function can take any number or arguments but can only have one expression. Okay, this is we define our column token, our column entitas bernama in this code, and after that we make self group by the column kalimat. After that we can print the sentence. For example, this is the first sentence and it's tagging. In this line, we will convert each tag to corresponding integer ID using a tag to IDX dictionary. Doing so saves a lot of memory. As I explained before, that to use embedding Elmo, we have to make our input to be sentence, and this is the code. X is refers to kalimat, I mean to token in our column, the sentence must have a same length. So we, from the default by preprocessing, we would like to use X as our new parameter, and max length is none. And we have to padding post. Padding post, it means the pad will be in the end of a token. This is the example of our first padding sentence. And we have to do the same things to the tag token. This is, for example, because the tag token we already make to IDX to integer, and this is the padding from our tagging. Now that we already have a sentence for sequence for sentence and sequence for tagging, we can split the data set into training set and test set. We use from scikit-learn. We use test type 0.2 and random state is 2018. Xtrain is the training part of the first sequence. That's our sentence, and xtest is the test part of the first sequence, and ytrain is the training part of the second sequence. Second sequence, it means our tagging, and the yet is the test part of the second sequence. Now we try to use Elmo embeddings. In Elmo embeddings, we have to install Torch because it's the requirements of using Elmo. Next, from this, we know that we successfully installed the Elmo for many lengths. Okay, and next, we have to change the Elmo for many lengths director to our director. This is the Elmo for many lengths folder. Okay, now we can use the embedder. We import the embedder from Elmo for many lengths. In this line, we have to initiate our Indonesian. We have to initiate our Indonesian pretend Elmo. Folder 158, it means Indonesian pretend Elmo, and our bit size is 128. Okay, for example, we have two sentences here. The first sentence consists of 6 words, and the second sentence consists of 10 words. The name of sentence we make is sense, and now we will return a list of numpy arrays, each with the shape and embedding size. We initialize the sense to Elmo. We make that sentence to Elmo. And this is, we make training Elmo to get our Elmo vector And we use output layer min1 because min1 is default by the Elmo, and this is the vector Elmo we get from the first sentence. The first sentence consists of 3 words. It's once, true, 3, 4, 5, 6. To know the shape, we have to run this code. From this code, we can now know that there is six words in the sentence, and 1024, it means the length of the Elmo. So one word can have a 124 factor. This dimension is default from the Elmo. That's all about our implementation. For your attention, sir, and ma'am, would like to say thank you.